Welcome to video 1 of the Unit 3 test review. This is going to be a 6-part series as we have 6 pages of this review. So let's go ahead and jump right in and take a look at the first 4 questions of the review. Question number 1 says the ratio of the angles of a triangle is 2 to 7 to 11. Find the measure of the angles. So this is the most important part. What is it that I'm trying to find? I'm trying to find the measurement of the angles. So the first thing I want to do is I want to take a look at this, and since I don't have a picture, I'm going to draw a picture. And I need a triangle, so here's a triangle. Alright, and it says the ratio of the angles. So the angles are 2 to 7 to 11. So this angle I'll call 2. And again, I don't know, that it's not that it's 2 degrees, 7 degrees, and 11 degrees. It's some multiple of 2, 7, and 11. So I'll call this 2x. I'll call this 7x. I'll call this 11x. Because that ratio means it's going to be some multiple of those numbers. Okay. I do know this about triangles. The sum of the interior angles of a triangle adds up to 180 degrees. So if I take my 2x, my 7x, and my 11x, and I add them all up, it's going to have to equal 180 degrees. Okay. Let me move this out this way. I'll try to just move some stuff around. Okay. So I need to combine my terms. 2 and 7 is 9, and 11, that's 20x. Equals 180, and then divide both sides by 20, and I get x to be 9. X is 9. Now this problem does not ask us to find x. It asks us to find the measure of the angles. So this angle here we said was 2x. So 2 times 9 is 18 degrees. And then 7x, 7 times 9 is 63 degrees. And 11x, 11 times 9 is 99 degrees. So the answer to this problem is 18 degrees, 63 degrees, 99 degrees. Question numbers 2, 3, and 4. The direction says determine if the following figures are similar. Circle yes or no. That's the first thing I have to do. Circle yes or no. Then state what theorem you used. Okay, so what theorems did I have? I had 3 different theorems that could have possibly been used. I had angle, angle. Let me put these in the back here. So we had angle, angle similarity. We had side, angle, side similarity. And we had side, side, side similarity. Those were the 3 different similarities that we used in this unit. So as I take a look at question number 2, I don't know any information about angles. I have nothing. So I am going to check and see if all 3 sides are proportional. So 3 sides, so 3 fractions. And this left triangle over here, this is the one I'm going to look at. I will put the sides in from smallest to largest. So 4, and then the next one is 10, and the last one is 16. Okay, and now I'm going to jump over here to this triangle, and again I'll go smallest to largest. So 10 is the smallest, 25 is the middle, and 40 is the large. Okay, and now I'm going to simplify these fractions. So 4 over 10, you can divide both of these by 2. So this reduces down to 2/5. So a 2 to 5. 10 over 25, you can divide both numbers by 5. It gives you 2 over 5. And 16 over 40, you can divide both of those by 8. And you get 2 over 5. So because these 3 fractions are all the same, these are, yes, they are similar. Yes, they are similar. And which one of the theorems did I use? I used side, side, side similarity, because all three sides are congruent to all three sides. I'm sorry, not congruent, they're proportional. Okay, so let's go ahead and take a look at number 3. Doing the same thing. So in number 3, I do see this angle and this angle are the same, so I do have an angle. So I'm going to have to check the sides. I'm going to check the two sides that surround that angle. Notice that they do have to be the sides that make up the angle. Had they given me, let's say for instance, this is 15, then I can't use side angle side. Right? It has to be the two sides that make up the angle, have to be the two that I know. So let's write my, I'll go small to large again, so this left triangle is 15, then 18. And the right triangle, 10, then 12. All right, let's simplify both of these, and we'll simplify them over here to the right. 15 over 10, those numbers are both divisible by 5, so that is 3 over 2, so 3 to 2. And then 18 and 12, those are both divisible by 6, that's 3 to 2. So those two are proportional. So they are proportional. Yes, we do have similar triangles, and it is by side, angle, side, similarity. Side, angle, side. Okay, and the last one, number 4, still doing the same stuff. Okay. I know this 53 is here and 53 is here, so I do have one angle, congruent to one angle. 82 and 45 are not the same. So I should probably find this missing angle up here. And I can do that by doing 180 degrees is equal to 53 plus 82 plus that missing angle. So I'll just call it X for now. So if I subtract 53 and 82 from 180, I see that 45 is that missing angle. That missing angle, it has to be 45 degrees. So this one here has to be 45. And now I'll double check my triangles again. I see I have 53, I have 45, and 45. So I do have two congruent angles. That is enough to have angle, similarity. So that one is good enough to have angle, similarity. The last thing that I will say, make sure you study the side splitter theorem. The side splitter theorem proof is in section 3.4 of your notes. If you do not have the notes anymore, you can click on Files here in Canvas and go to the 3.4 notes if you would like to find it there. That's going to do it for video 1. I'll see you in video 2.